Welcome back. So our lesson for 2.7 in Algebra 2 is a nonlinear functions unit, and we're going to talk specifically about the absolute value function. So let's explore a little bit on our calculator as to what the absolute value function looks like and what it looks like when we transform it. Opening your graphing calculator, we're going to go to the y equals menu, clear out anything that's old from a previous problem. Loading. Close. All right, so I have an old Algebra 2 or pre-calc question there. Let's get rid of that. All right, so y equals, in y1, let's type the absolute value of x. So the easiest place to find the absolute value feature is in the math menu. If you press math, and then you go over to where it says NUM, numerical, and then absolute value is ABS, the very first one. Now on the newer calculators, it's going to show up as an absolute value bar. On the older calculators, it's going to show up as ABS with a parenthesis opening for the function. So we're going to use our variable key. And then if we all have the standard window, so go to Zoom, and then these are the pre-programmed windows. Standard is your -10 to 10, -10 to 10 window. So choose standard. And there we go. Now it doesn't indicate on the calculator that there are arrows on the ends of this function, but there are arrows here and here. So if we think about what's happening is y equals the absolute value of x. It took the line y equals x, which, you know I can't graph, but it would have been this line, right? And then the absolute value feature takes any output that was negative and it changes it to a positive. So like for instance, right here, this was ordered paired -2, -2 originally for the identity function, but it's going to take this -2 y value, the absolute value of it, it's going to pop up here to +2. That's what the absolute value function does. All right, I should get rid of all that ink though, because the next thing the next thing we're going to do is we're going to graph. Now, if you wanted some points, remember your table, if you have it set up to autofill, which mine is, it's going to give you a whole bunch of ordered pairs. Plot a few, notice that what we're going to consider the vertex, the center of the graph, to be at 0, 0, and then you're going to see some symmetry as you graph it. So pause the video if you need to take a moment to graph some of these, and when you're done, you should get something that looks like that. So I am going to move on to the next question. I'm sure you guys can plot points fantastically. Oh, but you know what? Let's talk real quick about. Oh, I have this graphed, right? So bad. Okay. Let's talk about the domain and the range, because we just got done with a lesson on domain and range, and now that we have new functions, we're going to ask you for domain and range all the time. Remember, domain is how far to the left and how far to the right the function stretches. So these arrows indicate that it goes forever to the left, and it wouldn't stop, and then forever to the right. The range, remember, is the lowest y value up to the highest y value. So there is a definite starting point for the y's at 0, and then it goes up forever to infinity. So keep in mind domain and range, that concept's going to come back again and again and again. So let's graph the next couple on our calculator, but let's leave what we're going to consider the mother function in y1. So go down to y2, and my goldfish memory already forgot what we're graphing, x minus 2. And let's see what the difference is. So the absolute value of x minus 2, make sure you hit the subtraction sign and not the negative key. That would be a big difference. And that red one is the new one. So I don't know if you can tell on your graph, but even my old eyes can tell that it's been shifted to the right 2 units. So when I go to my table and grab some points off of the y2 this time, for the y value, you're going to notice that original function has been shifted right too. So go ahead and pause the video if you need some time to graph, but I'm going to graph my new guy right here. Very poorly. So again, I could come up with domain and range pretty quickly. The domain still is going to be -infinity to infinity because it goes forever to the left and to the right. It cannot be bounded. The range is actually still going to be 0 to infinity. I know it shifted to the right, but that doesn't affect how high or how low it started. So this next one, going back to your calculator, and you could go down to y3 if you wanted to, or you could go ahead and just change y2, say x plus 3. And you probably have a guess as to what this is going to do. There's the mother function, and there's the new shifted function, which has been shifted left 3. coffee break. Clearly. All right. Those of you who know me, you know it doesn't matter how early it is. I drink coffee all day long. So bad. All right. So the vertex, instead of being at 0, 0, is over here at negative 3, 0. Now, when you guys are graphing, I expect them to look way better than what I just did. This is awful. All right. Guess what? Domain. Same. Oh, gosh. Range is still 0 to infinity. Has not changed. So if we're trying to kind of make a generalization here, when there was something inside of the absolute value bar, that shifted our function horizontally, but did you notice it kind of did opposite of what most people would have anticipated? A lot of kids, when they first learn this, figure that x minus 2 means shifting left if they had to guess. It turns out it actually shifted it right. We'll talk about why that is later. All right, so this next one has an absolute value of x, and then close the absolute value function with a plus 2 off to the side. So get rid of y2, or at least edit it. Delete that, get out of the absolute value function, and then plus 2 out of the function. So make a prediction real quick before it graphs. Don't spoil it. Is that what you thought would happen? It shifted up 2 units. And then while we're at it, since I have the screen open, the next one of absolute value of x minus 4, can you make a prediction as to what that would do? I'm going to go to y3 and graph it. Plus 4? No, minus 4. Make sure it's a subtraction sign. Haha, is that what you thought of it? So go ahead and pause the video, take a moment. I want you to graph each of those problems, and then we'll talk about what generalization we could make. So, again, in a perfect world, I'd graph really well, but it's not a perfect world, people. There's that guy. And, oh man, I missed. Yeah, that was a little better. Okay, so, man, I can't even draw arrows today. It's going to be a rough moment. Domain and range. This time we will see a little bit of difference on the range. The domain is still going to be negative infinity to infinity. And the range, remember, is lowest y value to highest y value. So because it's shifted up 2, the range now begins at 2 and goes to infinity. So here the domain is still negative infinity to infinity, but the range, because it started at negative 4, is from negative 4 to infinity. Very good, very good. What happens when you throw a negative in front? I wonder. Let's find out. So grabbing our graphing calculator. Just gonna clear out y2 and y3. Throw a negative in front, then pull up the absolute value bar. Feature. Okay, graph. There's the original. There is a new guy. So a lot of kids say, oh, it's been flipped. And that's usually the word that kids associate with this transformation. Oops, my file. The actual term of what has happened to this function is it's been reflected over the x-axis. The old geometry term, right? Reflected, reflection. But specifically over the x-axis. So all of your y values that, like for instance, originally we had a y value of, or ordered pair of 1, 1. The y value is now going to be the negation of that, so it's going to be the ordered pair 1, negative 1. So your new function. Oh man, so ugly. Sorry, guys. You know, never was good at art. Okay, so the domain is still going to be negative infinity to infinity. I think you're sensing a pattern here, right? The idea is that there's no restriction as to what I could use for x. I could literally plug in anything I want into this function and still get a feasible answer. The range, however, remember it's lowest y value to highest y value. So since this goes down forever, it actually begins at negative infinity, and then it continues on until it hits this point, and it stops at 0 with a bracket, because there is an ordered pair at 0. What happens when you throw a 3 in front? I don't know. Let's find out. So let's edit y2 and just say 3 times the absolute value of x. Let's see. Original. New guy. So the vertex hasn't moved. It's still at 0, 0, but a lot of kids refer to this as being skinnier. The graph is skinnier. That is true. That is what's happening. The idea is the y's are going up 3 times as fast as they used to go up. So the original one had a ordered pair at 1, 1. Well, the new guy's going to have an ordered pair at 1, 3. And it's going to keep continuing up, you know, at a faster rate. Oh, gosh, golly. Okay, pretend. That totally worked out. So main and range haven't changed from the original mother function, remember? But it is definitely going to look a little differently because slope of the branches is what we're going to call that. They are going up at a faster rate. They're going up 3 over 1. All right, speaking of slopes of branches. Graphing calculators are amazing, right? There's a reason they cost $150, but there might be a time in your life when you can't use a graphing calculator, so you have to have some knowledge of the function. Plus, as we go through Algebra 2, you're going to realize a lot of these function features keep showing up in all the functions we learn. So the quicker we kind of understand the generalization form, the easier it's going to be on us as we transfer from absolute value function to square root function to cubic function and so on and so on. So most kids realize that once they understand the general function, they don't need a graphing calculator. And in fact, the graphing calculator will slow them down. So let's talk about this. This guy right here, a times the absolute value of x minus h plus k, that is the general form for an absolute value function. And the idea is, f of x, remember, same thing as y. The idea is whatever is in front of the absolute value function, we're going to call our a value, and that's going to be the slope of the branch. We'll get to that in a second. Absolute value of x minus, and then we have an h value in the bars, and then we have a k value off to the side. Now, we kind of saw what that did as far as transformations. The h represents a horizontal transformation, right and left. The k was a vertical transformation, up and down. And we saw what the a did all sorts of fun, right? So the transformation and the location of the vertex are related to each other. Normally, the vertex is at 0, 0 unless it's been shifted. So the vertex is going to be located at h, comma, k. And the slope of the branch is going to be whatever this a value is. And it's technically positive and negative of that a value. We'll see why in a second. But the very important thing you have to notice about this function is that built-in negative sign right there. That's why when we saw the horizontal shifts, they kept going opposite of what we would have anticipated. So x minus 3 was actually a right 3 shift because that negative was a part of the formula. We'll talk more about that coming up in a couple examples. All right, so the first one, let's try this without a graphing calculator. The vertex is going to be at whatever hk is. And you might notice that inside the absolute value bars, there's subtracting of nothing, and then outside of the bars, there's adding of nothing. But that 2 in front is going to affect the graph. We'll see why in a second. So I can tell that this vertex has not been shifted over, up, or down at all. So it's got a vertex at 0, 0. It's a different color because I can't see that. And then the slope of the branch is the a value. So 2. Think about slope, guys. Slope is rise over run, yes? So it's 2 over 1. Here's where it gets kind of confusing. A slope of 2 over 1 for a line means we'd travel up 2, right 1. Normally for a line, we could also go down to left 1, but remember, this is absolute value. So instead of using this as a line slope, you have to just kind of go in opposite directions. So you're going to go up 2 units always, if it's positive, and then you're going to go both directions, left and right 1. So up 2, left 1. And that's because of the absolute value feature in the function. So slope rules for absolute value graphs and lines are a little different, but they are related to each other. So the domain is negative, infinity to infinity, and the range is 0 to infinity. Let's see here. It's pretty good for me. All right, so the next one, vertex. Remember, it's at h, comma, k. So I noticed that there is nothing off to the side, so the k is a 0, but the h, remember, that negative is a part of the formula. So when it says x minus h is the same thing as x minus 3, that means h is 3. You hear my little son back there talking to himself. Logan. We got slope to talk about, man. All right, now the a value in front here, there's an invisible 1, so it's like 1 over 1. So as far as slopes for absolute value, that means I'm going to go up 1 because it's positive 1. And then I'm going to go right and left 1 once I plot the vertex. So vertex at 3, 0. So this function's been shifted to the right 3. And then slope of up 1, right 1. But instead of down and left, we're going to go up and left 1. There we go. Domain is still negative infinity to infinity due to the arrows and the non-restrictions. And then the range is still going to be 0 to infinity. I know it was shifted right, but that does not do anything to the range. Okay. So, next one, vertex, remember, is at hk. I noticed that there's nothing inside the absolute value bar, so that's a 0. And then the k is a 4. So 0, 4 is my vertex. And your slope of your branch is 1/2. So it's positive 1/2, which means we're going to travel up 1, and then both right and left 2. So what you're going to notice here on this absolute value graph is he is wider than normal. He's going up half as fast, which produces a slowly to rise, or kind of, a lot of people call it the fat graph. The larger the denominator for these fractions, the wider the graph is because of the rise over run relationship. So domain is still negative infinity to infinity. Someone usually asks at this point during class, is it always going to be that for absolute value functions? And the answer is yes. And the range, careful, this time it was shifted up 4. So that means the range begins at 4 and goes to infinity. All right, this next guy. Now be careful, inside the absolute value bars, remember there's a built-in negative. So when it says x minus h and it ends up being x plus 2 when it's simplified, that's because the h was really a negative 2. That was why it changed signs to a positive, quote unquote. So the vertex is at negative 2, comma 1. A lot of kids say, can I just take the opposites of whatever's in the bars? If that helps you remember, that's fine. That is how mathematical formulas end up working algebraically. Not actually what you're doing, but if it helps you, then go for it. Slope, remember, is the number in front. There's nothing there, so there's an invisible 1 over 1, which means that we're going to rise up 1 and then go right and left 1. So vertex at negative 2, 1. And then slope of up 1, right 1, but also up 1, left 1 because of the absolute value. Wow, shaky. All right, domain, still a negative infinity to infinity. The range, however, it's been shifted left 2 and up 1, so the range starts at 1 and goes up forever. I'm having trouble writing infinities today. Sorry about that. If you're having trouble writing infinities as well, just draw, like, you can turn your paper sideways and draw an 8, or you can draw 2 circles next to each other. I will never know the difference. Clearly, I don't have good handwriting. All right, see how quick these go without the calculator? You really don't need it. The vertex for number 11. Remember, it's hk with a built-in negative in the h. So the vertex is at 4, but it is a negative 2. The slope of the branch is 3, so we're going to write that as 3 over 1, meaning we're going to go up 3 units and then right and left 1 unit. So vertex at 4, negative 2. Slope of up 1, 2, 3, right 1, and 1, 2, 3, left 1. Nice symmetry to these graphs. If only I could draw. And, oh, I'm going to take that as a win. All right, domain, negative infinity to infinity. And range of, watch the y value, it's down at negative 2. So negative 2 to infinity. All right, some kids like to generalize. Okay, so is the range always a to infinity? It is if the a value is positive. If the a value is negative, which we're going to see soon, the range is going to be backwards because it's been reflected. So I don't want you to generalize so much where like you're acting like a robot who just plugs things into formulas all the time. I want you to look at the graph, think about what the graph looks like. You know, a lot of us are very visual. So even something in our brain that is graphed is better than just blindly following a formula. I don't like following formulas because that means I have to memorize them and that's no good. All right, so our h, remember there's a built-in negative. So inside those bars, it's really x minus a negative 5. That's why it says x plus 5. So the h is negative 5, the k is 3, and your slope of your branch this time is negative 1 over 1, of course. So because the slope is negative, that means instead of rising 1, we're going to drop 1 and then go right and left 1. And that's what's going to cause the reflection of the function. So vertex at negative 5, 3. And then slope this time of down one, right one, down one, left one. Look at that. All right, so domain, big news, negative infinity to infinity. Range, let's talk about this. Remember, range is how low does this go to how high does this go. So it starts down, like it goes forever. So negative infinity is the beginning of the range boundary, and then it stops up here at 3. So in that case, the range interval was negative infinity to k because the reflection, a value being negative. Like I said, not really interested in formulas right now. Vertex. -1, -6, sound good? Because of the negative negative, that's why it's plus. Slope of the branch is 1/4 positive, which means we are going to rise 1 and go right and left 4. Denied that phone call because you guys are more important. All right, it's Mr. Abruzzo. All right, -1, -6. And then your slope is rise 1. This is going to be a fat graph. Okay, 1 and then over 1, 2, 3, 4. Up 1 over 1, 2, 3, 4. 1, 2, 3, 4. Can't count. Wow. Oh, that was like a really good job for me. All right, the domain is still negative infinity to infinity. And the range this time starts down here at, well, I don't know if I graphed it well, but it'll start at -6 and goes to infinity. All right, this next one has like the whole shebang going on. It's got a horizontal shift, a vertical shift, it's got a reflection, and it's got a weird like a value, so the stretch of the slope of the branch is going to be a little different. So the vertex is at -3, 7, negative because of the built-in negative here. Slope of the branch is -2/3, which means when I travel, I'm going to go down 2 units, then right and left 3 units. All right, so -3, 7. Watch it. Okay. And then slope of the branch is down 2 units, right 3 units, down 2 units, left 3 units. I feel like I didn't count that right. 1, 2, 3. Yes. 1, 2, 3. Okay. Ooh, that's ugly. Okay, so domain, negative infinity to infinity, and range, now careful here, it is reflected, so the range actually is unbounded on the bottom. So negative infinity up to 7, and it does have a point at 7. So that was fun, graphing given a formula. But what if we flip that around and I give you a graph, and then you have to write the formula? Let's see if we can synthesize all this together. So remember, our equation, and you can write f of x or y at the beginning, I don't really care right now. Our general form is a, and then x minus h, absolute value of that, and then plus k. So we need to find a few clues. We need to figure out where the vertex is, because wherever the vertex is, that's going to be my h and my k. And then the a value is going to tell you a lot of stuff, right? It's going to tell you whether if a is positive, that's because it's going to open up. If a is negative, then it's going to be reflected and opening down. And the slope of the branch itself is also going to help you. So let's start filling in some information here, guys. F of x is not something we fill in. Let's talk about the a. Do you notice that this is opening upside down? So I already know the a value is going to be a negative something. That something is going to happen if I can figure out slope. So slope is from the vertex to one of the branches ordered pairs. It doesn't matter which one you go to. So me, it's already graphed. I'm thinking I should just count for slope instead of doing slope formula. So to go from this point to this point, it travels 1, 2 units down, and then 1, 2, 3 units over. So remember how we already talked about whether it was positive or negative? I don't have to worry about like, oh, but down and right, that's negative. I already worried about that. The issue is if you went down and left, to an Algebra 1 student, that's a positive slope, but we know better. We know that this is the absolute value function, and because it's reflected, it's got a negative a value. So that's why I take care of the sign first, count for slope. I'm almost home for you guys. This is going to be so good. So the h and the k are given to you right here. This is h, and this is k. Put them in the formula. So x minus the h, which is 2, and then plus k, which is 1. If I had a mic to drop, I would. All right, so this next one is same general form. We just got to find some things. So let's start with the sign of our a value. Is the a going to be positive or negative? Well, since it's opening upwards, we're going to have a positive a value, so you don't have to write down positive, but I wrote a note to myself so I don't mess up. The actual a value, though, the slope of the branch, we're going to have to figure that part out. So, okay, if I was giving this problem to you like on a test, I would have marked this ordered pair as 3, 0, because this is up for debate, right, as to which ordered pair it is. So the slope goes up 2 units, right 1 unit. So that's a slope of 2 over 1, which we would, of course, just write as a 2. And we already decided it was positive because of the way it's opening. So 2, absolute value of x minus something plus something. Now, I think I'm going to have to erase this plus sign, and I'll tell you why in a second. X minus h, that is a 2. But adding the k value, I wouldn't say add a negative 2. I would just say minus 2. I don't know why I changed the way my 2's look. One of life's great mysteries. All right, so that's our great lesson on graphing absolute value functions, but also taking a graph and writing it into the general form. Domain and range were covered. It is a very particular function, but it's going to be heavily related to all the functions we do. So keep all these components of the general form in mind.